evening, campers. Welcome to what's going to be the first of a good few videos that we're going to be filming on the whole Chademo fast charging interface. As had been noted on EVTV a few weeks ago, Jack had managed to secure a source for these Yazaki fast charging inlets at a reasonable price, and had made them available. Now, in this country we have quite a lot of Chademo compliant fast charging stations. So much so actually that it does actually make, let's do that again. There are quite a few fast charging stations here, I believe something in the region of 50. Now, this being a small country as well, it means that long distance trips for OEM EVs of the likes of the Nissan Leaf, etc. are quite feasible thanks to our Chademo fast charging interface. Now, it's been something that I've looked at in the past, and indeed I did have some initial investigations into it a few years ago actually again. I have to cut that word out. Now, the difficulty at the time was this guy, and I did manage to tunnel into Yazaki a bit, and I got speaking to a UK salesperson, but it was the usual sort of unobtainium approach to trying to get one of these sockets. So it wasn't actually until I could get my hands on one of these vehicle inlets that I figured it would be worthwhile actually, this is when we turn into the actually video, actually getting involved with making a interface. Now, I know that Jack had and does intend to use his JLD 505 system to achieve that, and I think I will probably use that myself, but in the meantime I have a fast charging station literally about maybe 3.5 miles from where I live, and there's actually two of them on my commute to work, so it would actually be very helpful for me to have that kind of an interface on my vehicles. Now, the Chademo standard is, the Chademo interface I should say standard, is actually comprised of two blocks. The first is the physical connections. There's some 12 volt signals that go between the charger and the car. And then there's some CAN bus data transmission that occurs constantly between the car, sends commands to the fast charging station that basically tell it how much current and voltage to pump out. So the electronics is not that difficult, and the CAN bus interface thing probably not too difficult either. I've got a little bit of a hill to climb on some of the programming, but recently with the release of the CAN GUI board for the Arduino GUI, that has actually made things a lot easier to build. So what I'm going to show you guys now is just a very rough cut of a prototype system that I'm building that I can take a car with this socket in it down to a fast charging station and see if we can actually command it to give us some fuel. So let's have a look. So let's take a very quick look at the high voltage side. Basically, we'll have our Chademo vehicle inlet, have the cable associated with that. And we'll have two of these Gigavac 500 amp contactors, one for each pole, positive and negative, that we will isolate the Chademo socket from the vehicle's high voltage battery pack. And that pretty much, what you see here, comprises the high voltage parts. So we're going to install this socket probably in the land yacht, at least temporarily, to test it. And we'll have an enclosure for these two contactors, and we just pipe the two high voltage lines into one side of them, and we'll take off a feed to the battery from the far side. So that's going to handle our high voltage switching. So let's take a look at the electronic side of things, to how we're going to achieve that. Okay, so let's have a look at the electronic bits that we're piecing together here to do our CAN bus communication and interfacing. But the first thing that we need to do, specifically for the CAN bus protocol, is to measure voltage and current. So we need to measure our current battery voltage, and we need to measure the current that the fast charging station is supplying to our vehicle. For that, I elected to use a LEM cab 300C current sensor for measuring current, strangely enough. This particular sensor is a expensive part. I believe it's something like $200 from EVTV, but it is very simple to use. One simply places a core of the cable, so our positive cable from our Chademo socket goes through the center of our current sensor. We then have a very simple 4-pin interface here, 12 volts ground, CAN high and CAN low, and this little guy basically transmits CAN messages, and we pick those messages up and we know how much current that our charger is supplying. And that is a very important element because according to the Chademo standard, we need to report the current to the charging station every 100 milliseconds. So we need to say, for example, if we want 50 amps, we need to command that to our charging station and measure that current and ensure that that is the current that this is a crazy video. We have to ensure that that current is correct. So we measure the current that the charging station sends to us, and we basically control it. In this instance, the car controls the fast charging station. So that's how we're going to measure current. Is it the cheapest way to do it? No. Is it the way I would, ultimately do this if I was going to produce this in some fashion? No. But for onesies and twosies of, this is just a very nice solution. Voltage measurement. There's a myriad of circuits out there that will allow isolated voltage measurement. I used a circuit based upon an application note for the Avago HCPL C870 voltage monitoring chip, which is built on a little card here. This is our main card. It's just a piece of strip board that I'm anchoring all of our components to. Now, this particular circuit takes the high voltage input from our battery through a resistor divider and isolates that and gives us a representative signal in the 0 to 2 volts range that we can feed into our Arduino GUI processor, run some simple maths on that, and be able to read the high voltage traction battery without sharing a ground or any other crossover signals with our processor. So that's on the card here. Also, we have a little 12 volt 2 amp relay, which I'll explain the function of that presently. And the heart of the system is an Arduino GUI card, which is based upon the Atmel ARM3 processor, which is a very powerful 32-bit microcontroller. Now, again, as I said earlier in my tongue-tied video, we have two layers to this. We have some interface layers around 12 volt signals, and we have CAN bus. So let's look at how we're going to handle the interface, the 12 volt signals. So what I'm doing here is I'm building a prototype. I'm not building something for production at the minute. I'm building a prototype that I can test quickly and get the bugs out of it, and we can see then about making a much neater PCB card that has everything properly integrated into it. So what I elected to do was to take a commercially available so-called proto shield, which is what this guy is. It's actually designed for the Arduino Mega, but it has pretty much the same pinout for the GUI. And on this we have some passive components. We have an Avago ACPL 847 quad opto coupler, and a few, as I say, simple passive components, transistor, caps, resistors, that sort of thing. And on this card we implement the 12 volt switching as required by the Chademo protocol. And this card here with the pigtail here, where I've got everything labelled up as to the various signals, we're going to sit that guy pretty much just in on top of our Arduino card, and that is our processing card, our 12 volt signals interface, our voltage monitoring and our current monitoring kind of taken care of. Now the last piece of the puzzle is the CAN bus interface, and again that's been made easy by the recent availability of the CAN GUI shield from EVTV, which gives us a it gives us two CAN bus interfaces, one on this 9-pin D socket and one just on a screw terminal, which is very important for us by the way. We've also got an SD card slot, two CAN controllers, or sorry, two CAN transceivers for the CAN bus, and a E2 chip for storing data. And this guy here will just plug in to the top like so, and pretty soon we have ourselves a sandwich here of boards giving us all of the necessary components that we require to implement a vehicle side Chademo interface. Got a simple plastic box, and I've mounted a 23-pin amp seal connector. Again, this is the very same one as on the DMOC, and it's the same type of connector that we used on the 1000 amp controller that we built for the yacht. So I've just screwed that in there, screwed into the front panel. It's crude, it's not even straight, but it's in there very securely. And we'll take the whole affair then ultimately, drop it in here into our box. We'll screw that guy down to some mounting points, terminate all of these signals onto our amp seal connector. We'll have our external current sensor mounted in our battery pack. I'll run a USB socket out to the front here, and we're pretty much good to go. So there's a bit of build in it. but we're well on the way with this side of things, and we'll come along as well then, and we'll have another box that'll hold the two contactors and handle the high voltage stuff. So just to round out, here are some very simple schematics of the actual Chademo interface. So as we can see from the top, let's say from the top right hand side, we can see where our contactors in the vehicle are, two contactors, and coming down from that then we have the simple 12 volt signals that we described and how they interface between the charger and the vehicle. And down the very bottom you can see the CAN H and CAN L, which is CAN high and CAN low. And down then underneath that we have our charging sequence flowchart, which basically tells us the order in which those signals kick on and kick off, and how they have to operate, etc. et al. Now I will be going through all of this in much more detail when we're actually hopefully writing a bit of code for this thing. If anyone wants to help me on that, then by God please do, because I'm going to get bogged down in it. So yeah, that's pretty simple. I mean, if you actually look at it, there's not a lot of lines on that drawing. In fact, you only really need signals F, G and K to implement the interface, and CAN bus obviously. So that's that part of it, folks. So sorry for the mumbo jumbo earlier, folks, and a bit of I suppose not very concise description here in this video. It's late. I've done a good bit of work on this thing tonight, and I've done that after doing a day's work, so I'm kind of spinny a bit in the head. So stay with us please. This promises to be an interesting, I won't say sideline, but an interesting EV related project, and we'll have more videos soon on this and on the Panzer project, and I've also got a 10,000 mile update video coming for you from the land yacht. So as always, thanks for watching, thanks for subscribing, and we'll see you all soon.